So this is exercise 1F, question 12. And it starts by saying there's a function f from the domain S onto R, and the rule is f of x equals root 4 minus x squared. And S is the real values of x for which f is defined. And the first question is to find S. Let's just move that up there. So for f to be defined, then we've got a square root sign. So what's inside the square root must be non-negative, otherwise they can't take a square root. So 4 minus x squared must be greater than or equal to 0, which means 4 is greater than or equal to x squared, which means x is between, inclusive, the square root of 4 in the plus and the negative sign. So x is between minus 2 and plus 2. That will give you x squared less than or equal to 4, which will give you 4 minus x squared being non-negative, and therefore f is defined. Now b, the range of f. Well, f is the square root of a number between 4 and 0. 4 minus x squared can only be no greater than 4 and no less than 0. So f is the square root of 4 minus x squared, which can be between the square root of 4 and the square root of 0. So the range of f is 0 to 2 inclusive. The range of g is x squared plus 1. Well, x squared can be from 0 to infinity. So x squared plus 1 is going to be from 1 to infinity. Okay, now we come to the slightly more exciting bits, part C. State whether or not fog and goth are defined and give a reason for each insertion. Let's clear this page. Forgotten how to. So, we need to draw a little table about our functions f and g, and consider the domain and the range of both. So the domain of f is S, which we now know is minus 2 to 2, and the range is 0 to 2. The domain of g is R, and the range of g is 1 to infinity. Now, fog. If f of g exists, then we require the range of g to be inside the domain of f. Well, the range of g is not inside the domain of f. So in the case of the first part, the range of g is not inside the domain of f. Therefore, f of g does not exist. But what about g of f? So now we need to consider the range of f. Is that inside the domain of g? Well, the range of f is 0 to 2. The domain of g is R, so that's good. But the range of f is inside the domain of g, therefore g of f does exist. And that concludes question 12.